Good morning, friends. Today we are going to continue the next part of this unit. In the last lecture we discussed about the reaction and the reactivity of this particular alkyl halide. We have seen the three different mechanisms under which this reaction proceeds. First was the SN1 mechanism, then the SN2 mechanism, and last we have talked about the SNI mechanism. Right? These mechanisms are very important. Out of this one, a mechanism will be there in the exam. That mechanism will be either with direct name or say sometime it may indirectly ask by giving the example. Okay. Now we have to see the next part of this unit that has the factors affecting the nucleophilic substitution reaction. Today we are going to discuss the important thing. Now, which factors will affect the nucleophilic substitution reaction? As you will be aware that there will be the nature of the substrate, solvent, then nucleophile, leaving group. These things matters for this particular nucleophilic substitution reaction. We will talk about this particular thing. See, nature of the substrate. In case of the SN1 reaction mechanism, rate determined step is the formation of the planar carbocation. Hence, order of reactivity among the organic substrate will depends upon the stability of the carbocations formed after the ionization of the substrate. The order of substrate as follows: tertiary alkyl halide, then the alkyl halide, benzyl halide, secondary alkyl halide, and the primary alkyl halide. Means tertiary carbocation is very stable as compared to the secondary alkyl halide as compared to the primary. Then in SN2 process, what happens? The steric hindrance around the carbon site makes a huge difference in the rate of SN2 reaction. The central carbon atom is reactant and the product is tetrahedral. The central atom is reactant and produce whereas carbon in the transition state is bonded to the 5 atoms or a group. Hence, there will be an increase in crowding which gives high energy transition state. It leads to slower the formation of the product. Reactivity of the substrate, the order as CH3X, that is the primary alkyl halide, secondary alkyl halide, then the tertiary halide, and the SN2 it will be the exact opposite to the SN1 reaction. Then the next factor that affects the nucleophilic substitution reaction is that the solvent. As we know, we are carried out reaction in either the aqueous solvent or the non-aqueous solvent. This solvent is playing the very much important role during this reaction. Now here SN1 reaction will be favored by a polar protic solvent. What is a polar and a protic? Polar is nothing but there should be the charge separation. There should be the two pole formation. That means that there should be the positive negative charge separation should be there. Protic is nothing but there should be the proton. Protic solvent is nothing but there should be the proton. Means H plus atom should be there. Here water, alcohol, carboxylic acid, these are the protic, polar protic solvent. Then SN2 process requires the ionization of covalent bond which is encouraged by solvent and dielectric constant. Also, in SN1 process or the reaction, it is again the SN1 requires the ionization of the covalent bond, which is encouraged by the solvent and dielectric constant. For the SN2 reaction, it will be favored by a polar or protic solvent. SN2 process involves a reaction of an ionic nucleophile with the alkyl halide is suppressed in the presence of the polar protic solvent. Since polar protic solvent will interact the hydrogen bond more favorably with an ionic and then interact through hydrogen bond more more favorably with an ionic nucleophile nuclear and then with the SN1 process involves the reaction of an ionic nucleophile with the alkyl halide which is suppressed in the presence of the polar protic protic solvent. Since the polar protic solvent will interact through the hydrogen bond more favorably with an ionic nucleophile, then there will be the reaction between these particular reagents. Then the nature of the nucleophile. Next factor is the nucleophile. For SN1 reaction, the rate of the SN1 reaction is independent of the nucleophile. Weak nucleophile with low concentration favors the SN1 mechanism. Weak nucleophile with the low concentration will favor the SN1 mechanism, whereas the rate of the SN2 reaction is strongly dependent on the nature of the nucleophilic reagent. Strong nucleophile favors the SN2 reaction. Then the nature of the leaving group. The rate of the SN2 reaction is affected by the nature of the leaving group. Is affected by the nature of leaving group. Weak base of strong acid. Weak base of strong acid is the best leaving group. The rate of reaction is higher if the leaving group is stable ion and a weak base. In case of the alkyl halide, the order of reactivity is this is about the leaving group. These four different factors that we have seen. First one was the nature of the substrate, then the nature of the solvent, third one was the nature of the nucleophile, and the fourth one is the nature of the leaving group. These factors will responsible for the reaction to be proceeded through SN1 or say SN2 mechanism, that you have to remember. And the next part is the reactivity of aryl halide towards the nucleophilic substitution. Aryl halide are much less reactive in nucleophilic substitution as compared to alkyl halide. Example, hydrolysis of chlorobenzene. The lack of reactivity is due to the following reasons or following factors. Here example is shown hydrolysis of the chlorobenzene. You can see in the hydrolysis of the chlorobenzene, on the benzene ring chlorine is there along with the NaOH aqueous. You are going to refluxing more than 2 days in presence of the A catalyst. Cl will be replaced by the OH and NaCl will form. This product is not forming. In aryl halide, halogen is attached to the aromatic ring, hence do not undergo SN1 and SN2. Here in this case Cl group is attached to the aromatic ring, that's why it does not undergo the SN1 SN2 reaction. Nucleophile cannot attack from the side opposite to the halogen atom as in SN2 reaction due to the presence of benzene ring. For SN1 reaction to take place, the carbon halogen has to undergo fission, but the resulting carbocation is very unstable to take place. The carbon halogen bond is shorter and stronger. This is because the bond has partial double bond character as shown in the following resulting figure. This is about the then aryl halides are hence undergo SN1 reaction under the very drastic condition like high temperature and high pressure. Then we have to see the two different mechanism for this particular aryl nucleophilic substitution reaction. Please go through this part why it is not going undergo the SN1 or SN2 reaction. The reason we have seen in your next, that is your the next part, in that we will see the two different mechanism for the nucleophilic substitution reaction of the aryl halide. Okay, you got this concept. Very simple it is. In the resonating structure, what we are going to show, we are showing the below original electrode. Okay. Okay. Please go through this lecture well. If you are having problem, any difficulty, you can freely ask. Today we will stop here. Thank you.